Imagine opening a restaurant in a busy city, but the electricity company tells you the kitchen won't be connected for another 3 years. What a nightmare. Customers still arrive tomorrow, so what do? You rent generators, park them behind the building, and start cooking anyway. That's increasingly what the data center boom looks like. Every data center being built right now needs power immediately, not when the grid connection finally arrives. That gap has created a market, and the technology filling it isn't new. It's the old school gas engine. Modular, fast to deploy, fast to start. The same reciprocating engines that have powered factories, cars, and hospitals for decades. What has now changed is the scale. 5 years ago, a 20 megawatt distributed generation project was considered large. Now, Clarke Energy is working on 200 megawatt data center installations in the US and a 450 megawatt peaking station outside London, where banks of gas engines sit idle until wind drops and the grid calls for backup. Houston, we have a problem. But speed to power and decarbonisation don't always pull in the same direction. As my guest today puts it, the engineering department and the sustainability department don't always speak the same language. Alex Marshall is VP of Business Development at Clarke Energy, with 3 decades across biogas, combined heat and power, and flexible grid support. This episode isn't about whether gas has a future. It's about who controls the power when the grid can't. I'm Alejandro, filling in for Ed Porter. Welcome back to Transmission. Alex, thank you very much for joining us today to Transmission, our podcast. Can you first start by introducing yourself, what your role is within the energy industry, and what Clarke Energy does?
Yeah, thank you, Alex. So I'm Alex Marshall. I've been with Clarke Energy 18 years, originally a biologist and moved in through a strange route in the waste management sector, developing waste treatment technologies, which had a biogas output. And that biogas output is used in gas engines. And I worked my way through Clarke Energy many years, relocating here to the US almost 4 years ago now. I am a vice president of the Cogen World Coalition, and I sit on the council of the World Biogas Association. So Clarke Energy, we are the distributed energy specialist, part of RELCO. RELCO is what was Kohler Energy. And we focus on resilient distributed energy solutions. So from a Clarke Energy perspective, 30 years experience, we've seen the industry of local power ride a series of waves, whether that is the landfill sector, the biogas sector, combined heat and power, more recently flexible generation for grid support, in Australia, remote power for mining. And then, as we're here, obviously the big exciting topic is data centers. Well, we've been working on data centers for 10 years now. And we're starting to see some really exciting projects coming through.
And when you work with a new client, do you usually focus on some technologies? You look at all of the technology spectrum of power generation?
So our core business, we are the largest distributor of INEOS Jambacher gas engines, which is an Austrian gas engine. That kind of forms the nucleus of most of the projects we work on. However, one of my roles in Clarke Energy is to support the transition to new technologies for us. So what we do, if you're talking from a client perspective, we ask the client, what are your energy needs? What's your, electrical demand, your cooling or thermal demand? And then we would map on a solution to match that requirement. If we start to talk added levels of complexity, we can start to then look at, say, to the customer, well, the energy trilemma, what's important to you? Is it cost? Is it carbon emissions, or is it resilience or availability? And you can develop a hybrid solution with that trilemma, that triangle, to give the optimal solution for the customer. So, for example, we could integrate batteries, or we could integrate on-site generation of hydrogen. We could do a microgrid control system. We could put in solar and bolt these together based upon what the customer requires. And we have some specific suppliers, and then for other scopes of work, we are agnostic. Or we'll go in, we're a life of asset provider. So an EPC, engineer, procure and construct, but then with maintenance. So we'll give an interest in the facility for maybe 10, 15 years into the future.
You have been at the front of hyperscale data centers, as you mentioned right now, and recently in the US as well. Has there been a sheer moment when you realized the boom that was coming with a specific project or a certain year, and what did it translate to in your daily operations or your strategy for Clarke Energy?
Yeah, that's a good question. So from a marketing strategy perspective, we've been watching this market for many years. And to be honest, it has been quite frustrating. 10 years ago, we identified this as an opportunity, but the data centers were comfortable with grid electricity. They wanted energy generation as a backup, not for base load power. So we saw early projects, projects going into Ireland, small enterprise data centers, 1-2 megawatts, where it was next to an office. They had a requirement for heat, and that heat would be fed to the office. We did some early rail operating centers in the UK. And then one of the most exciting projects was at Citibank, where it was Green Investment Bank financed. This installation, again, on the small scale, they were converting the heat to cooling via absorption chilling, so combined cooling and power to demonstrate the carbon efficiency of that technology. Now, we started to see, historically for us, we were working on 1-2 megawatt projects across the market. Maybe 10 was an unusual one. A 20 or a 50 megawatt project was a unicorn project. Now we saw in Ireland, we had a 60 megawatt project, which we kind of shied back from a little bit, thinking, is this too big? Is it too much risk? Now that project is small for us. We're starting to see a rolling kind of pipeline. From our experience on that project and a further 90 megawatt project in Ireland, we were in the US, but still the US wasn't talking, when I arrived, really self-generation of power data centers.
Yes. On
the data center side, where we scored a 200 megawatt project recently, and wow, this kind of shows you that the world is on an inflection curve for the demand for the power. So I would say, once we saw that market move out of the Irish kind of example projects into the US and saw the growth rate here, that's when it's like, this is really, really big here, but also globally. We operate in Australia and India, and this wave is following other countries as well.
What is the biggest project you are working on right now in terms of capacity?
It's not a data center project. It's a peaking station project. We're just finalizing that. It's a 450 megawatt station outside London. Very similar technology to that for data centers. And that's also one of the opportunities for data centers. The peaking stations sit there and provide power when there's a fall off in wind or a fall off in solar power. And obviously the baseload power can no longer cope. So those units come on, signal from the grid saying price is high, meaning supply is low, and they turn on.
I see. And what is the advantage that these peaking plants can provide compared to batteries right now? Because we're seeing very big batteries being built.
Yeah.
What is their advantages?
So batteries typically 1-2 hour duration output. In the dunkelflaute, the low wind doldrums, the low energy doldrums of the winter, when you have no sun or wind for a week, those batteries simply just don't fit that gap. And batteries don't generate electricity, they store electricity. So gas engines and gas peaking stations will fill that gap when batteries can't do that. And don't get me wrong, batteries and engines work very well. They're complementary technologies because batteries can ramp very, very quickly. Engines can ramp quickly, but not quite as quickly as batteries. So you can marry those two technologies in parallel. So that's on the peaking station side. Incidentally, the early 90 megawatt project we did in Ireland for a data center was 40 megawatts base load for that facility, 40 megawatts flexible energy in support of the grid, i.e. the data center no longer being selfish, just thinking about their own operation, but actually providing residual grid support and then some redundancy in there to make full availability of the assets.
Okay, I see. And when a customer comes here in the US and asks for data center on-site generation, what is the typical setup of technologies that you have for data centers here in the US?
So what we see, we can offer the full suite of microgrid technologies, but in reality, data centers, we're looking at primarily, historically backup diesel. We're looking at baseload gas or bridging power gas, and then energy storage. And if the data center is more kind of energy conscious, environmental conscious, we'll see the deployment of combined cooling and power technology as well.
You also mentioned that you offer combined heated power solutions. What are the type of customers that go for that on-site solution rather than just pure power generation?
Well, that's a good question. And, the early reference project in London proved the concept. But in reality, data centers, they're concerned about speed to power. They're not necessarily concerned at the moment about efficiency. I think we'll see those customers go through a learning process themselves, and they realize that maximizing the value of every electron of the fuel is important. So if you're in a bridging solution, if it's 3 to 5 years operation, those solutions are less likely to want to see combined cooling and power because it means additional capital expenditure. So the facility still has to pay off its capital expenditure within that time frame. If they're talking base load over the life of the asset, then that becomes a lot more attractive and logical. And there's a greater degree of time to pay off that investment.
And from the projects that you're seeing now, what are the deciding factors for those developers to go for on-site generation rather than grid connection?
Well, it's simple. A, availability of electrons in the local network, or B, the ability to bring that level of power to that facility at a given point of time. So it's constraint.
Has there ever been an occasion where you said to potential customers, hey, this doesn't make sense, you should actually go to the grid rather than looking for on-site generation?
Well, normally the customer will know that in advance, but yes, if you've got very low electricity prices, typically where there's a nuclear power station which has got surplus energy, but even those power stations are being, hoovered up their capacity. So it's changing.
Okay. And what would you say are the biggest obstacles right now, generally, for deployment of on-site generation?
Location of the site, whether or not there's physical space to do that, the cost of power locally, the willingness of the data center operator to self-generate power, because data centers it's not their core business. So these are the sort of factors I think,
Did you have the need to say no to some customers due to supply chain reasons, a lot of backlog? Or
no, we haven't said no to any customers, but yes, lead times are expanding.
Yeah.
We still have an attractive lead time compared to some of the options right now, but yes, demand is high and it's no suppliers market at the moment.
Okay. And within the US, are you seeing a concentration of a lot of your projects in some regions or markets?
What we're finding is more along the less populated central states of the US, the likes of Utah, maybe more agricultural states like Ohio. These areas which have got lots of space, relatively cheap power, that's where we're finding a lot of the newer installations going in, where, places like Virginia are hugely crowded, over capacity, and you've got some challenges in those areas still.
You spend a lot of time publicly making the case for a net zero pathway in the future. And in that sense, what's the most defensible role for modern gas engines for the next 10 to 15 years, especially taking into account the transition to a net zero pathway?
Yeah, that's a very good question. And there's probably a series of steps that need to be taken. So even using natural gas, if you use combined heat and power configuration,
yes.
So you use the electricity and the heat, or you convert the heat to cooling, you can achieve a system efficiency of 90%. In almost all locations in the world, that still has lower carbon emissions than the grid electricity. So before we even transition to fully renewable fuels, the ability of CHP to deliver carbon savings is tangible and immediate.
Yeah.
The next level is time efficiency. So as mentioned before, the grid is on, there's more and more wind and solar on the grid, which makes the grid unstable. The data center operators and gas engine technology can support the grid in times of the true renewables being unable to supply. That's the next phase. Then if we work up that, you can also, on a more advanced level, you can add carbon capture. Post-combustion carbon capture is proven technology, widely deployed, and that CO2 is a valuable offtake product that could be taken. Then you talk about renewable fuels. So the gas engines deployed today can operate directly on RNG, renewable natural gas, molecularly the same as natural gas, the renewable fuel, or you can convert to hydrogen. And the engines are hydrogen ready and can operate anywhere from 0% hydrogen to 100% hydrogen with a balanced natural gas. So you can decarbonize at, intervals depending upon what's available locally, what fuel supply is there. And the other component is gas engines can form the backbone of microgrids, whether they be renewable fueled or natural gas fueled, integrating with solar, battery storage systems and providing that firm power when those two systems aren't fully operational.
And usually when clients come to you, you said the biggest reason is speed to power. Do they ever come to you for cost savings purposes? Have you seen cases where it was way cheaper for them to have on-site generation than connecting to the grid?
That's a very good question. So in the commercial industrial space, that is almost essentially the entire, objective for combined heat power plant. Rather than generate electricity or take electricity from the grid, generate heat from natural gas and use that on site, you put a CHP unit in to do those factors. And the aim is typically to reduce cost. So you'll see a return on investment within 1 to 2 years of operation in many instances.
And usually when you deploy a solution, you take care of operations and maintenance as well?
Yeah, that's where we come from.
Okay.
So we're a life of asset energy solutions company.
Yeah.
So rather than just engineering, procurement, and construction, we had maintenance to take the life of the asset into consideration.
Do you see a future where a coupling of renewables plus batteries will fully replace thermal plants, or you don't think it will come in the long term?
I think they'll certainly eat into the lunch of the thermal plants. The difficulty is, I think you're from Spain, and some of the challenges on inertia on the grid is, recently surfaced. So clearly renewables are good, but they need to also provide grid stability. So there's still the role of rotating equipment, i.e. thermal generation, in that platform.
You mentioned firm generation for grid stability in terms of voltage and frequency. But when we're thinking about on-site generation, which is an island, those services are not that much needed in terms of keeping the frequency in the grid. It's a micro island. In that sense, if the thermal plant is not offering that service to the on-site load, do you still think that there's an advantage compared to batteries coupled with renewables?
So islands, by their definition, are inherently unstable. So the generation assets have to handle with those loads. So AI is notoriously peaky, and you've got very large loads coming on and dropping off. That's where, using engines in parallel with batteries is very good, because you can have those two things working in parallel. We've done many projects globally where, for example, in Nigeria, we have a plastics extrusion site. The loading rates of those generators, because they can't connect to the grid, has to absorb those challenges. Those issues are serious, but they're normally kind of addressed through some sort of energy storage technology. So there's kind of synergies with those. So like ultracapacitors or battery energy storage systems. And these kind of hybrids are being deployed in the data center space.
Okay. And now that you have experience working in this distributed energy space in Europe, in the UK, and also in the US, are there any main differences that you see in the way the key stakeholders, the way they look into these projects, what value they see in them between the geographies?
Yeah, I think sustainability is higher up the European agenda. That's got a double, it's a double-edged sword. Yes, there's more kind of potential resilience from renewables, but also it's pushing the prices up in Europe, which I think people are starting to feel the pain. US, maybe a little bit more gung-ho on the fossil fuels, and they would benefit, I believe, from more energy efficient thinking, because these fossil fuels are finite as well. If we're using them, let's use them efficiently. So I think those are probably the two main considerations. Data centers in Europe, for almost certainly, if they're gas fueled, are going to be CHP from the outset, whereas in the US, the consideration is different.
Before we jump into the final section, is there anything that should have asked you that would be interesting for our audience?
So one of the points we can perhaps mention is the potential for the production tax credit. Combined heat and power, under the previous Inflation Reduction Act and the previous government's policies, fell between the cracks because it wasn't a fully renewable technology. It's an energy efficient technology. The current administration is more keen on natural gas, but still some of these support mechanisms aren't favoured. One of the ones that's tabled at the moment is the 45Y production tax credit, which had a note from the Treasury recently that they approved of this, yet it hasn't been ratified by the federal government. What this would mean is it would improve energy efficiency and speed to market for combined cooling and power in the data center space. So what would happen in essence is, potentially at the outset of a project, you could monetize the production tax credit for the thermal value of the energy over the life of the installation at year one by giving those credits to a bank. They would monetize that, give the developer a sum of money, which could then be used to offset the cost of the absorption chilling. That would massively help the path to improved efficiency, reduced carbon emissions, and also, better use of the domestic fuel reserves, which shouldn't be burnt off too quickly.
Yeah. And what technologies specifically can access this 45Y credit? Is it combined heat and power, but all types of thermal plants, or what thermal?
This is combined heat and power, and it's primarily aimed at larger thermal plants.
Okay. Are you using natural gas, also, for example, coal?
That's a good question. I don't know the answer to that. Certainly natural gas, biogas, hydrogen. I don't know the answer on coal.
Okay, perfect. Thank you. And whenever we have talked about customers putting first speed to power, other customers looking at costs. For the customers looking at emissions, and mostly that could be Europe, are there any customers in the US that are really taking care of reducing their emission levels? And if that's the case, what type of customers are those usually?
Well, the very big names in the market, I won't mention any clearly, but you'll have these very large corporations, and they'll have an engineering department tasked with, putting an installation to the ground very quickly. And then you have the sustainability department talking about the importance of reducing emissions. These two functions don't really talk to each other.
Yes.
It's the kind of the business need functions which are taking priority, clearly. And I think they would benefit from having probably a greater integration and a greater say. A lot of people talk about their carbon goals, their decarbonisation goals, their pathway to net zero. I think realistically, a lot of these are very high. I don't think many people will actually achieve that. There will be one or two that do that, but I suspect it won't be the entire market.
Okay. And just jumping onto another topic, which I found out of curiosity, very interesting, is what is the actual business model of Clarke Energy in itself? Is it having the final customers pay for all of the capex of the new plants and then having revenues come from the service operating and maintaining those plants, or what exactly is the business model?
Simply engineering, installation, maintenance. We supply a piece of equipment, we charge, we have some margin on selling the equipment, and then we have a long-term service contract which we support availability, and we receive regular payments. So those two things form our secret sauce. It's the upfront installation, a long-term service tail.
And when you get access to those 45Y credits, is it you, Clarke Energy, the ones that are managing the value of those tax credits?
No.
So it's the final customer?
That would be the final customer, it's their responsibility. It would be their benefit to install that. We're not a developer. We typically don't own the assets. That would be the customer. Where we kind of differentiate ourselves is a quality installation backed up by reliable after-sales support. There's a lot of people at the moment putting equipment in, and we find this on each market. There's a series of waves. The early first movers, they just want low cost, speed. They realize that, on-site power is about availability, and availability needs to be done by quality engineering at the outset, and then trained, reputable service technicians at the tail. And there's already not enough of those individuals in the US in particular, but globally. And we're one of the few companies that can bring that to market and do that successfully. So there's going to be a learning curve, I think.
And can you tell us about a specific project that you've been very proud of being part of it, be it for an innovative solution, an innovative setup, or a very tough region with high prices whatsoever? Can you tell us about a specific project?
Yeah, well, there's several of them. We've worked on projects in Ireland which recover the engine exhaust and convert that to beverage grade CO2, i.e. the carbonation in drinks. That's quite important. There's some major biogas upgrading facilities in Indiana where, we provide renewable electricity, renewable heat, and renewable natural gas for injection into the network. I think that's really good. The early combined cooling and power project with Citibank that we did 10 years ago, that's demonstrated that technology in the market. So there's many kind of innovative application-specific projects we've done. We've done compressed natural gas projects in remote areas of Nigeria, where they've historically relying on diesel generation as baseload power. And then we're also doing hybrid installations. We have a hybrid engine battery project, one in Romania, one in Connecticut, and one in Australia, proving the concept of these technologies in different countries, not just in a very narrow one geographical mindset.
And usually in all of these countries that you mentioned, is it industrial customers usually, also data centers? What type of use cases are we
It ranges, data centers, commercial industrial facilities, oil and gas facilities.
The one in Nigeria,
farms.
For example?
Nigeria is a manufacturer.
Okay, great. And in Romania?
Romania is a grid support system. Perhaps also interesting for the data center market is we find in Eastern Europe, you have lots of legacy Soviet district energy networks. These are coming to the end of life. They're historically large old inefficient turbine fuel power generation. We're starting to refurbish those pieces of equipment. But data centers, if they had joined up thinking, could link next to these networks and use the surplus heat from the on-site power generation into those networks to offset some of the local loads.
That's actually a very interesting point. So all around Eastern Europe, there are these facilities that are outdated, old, not used anymore, and you can refurbish them and bring some of the customer load to those locations to restart the plants, actually make use of them. Is that correct?
So we are doing refurbishment of existing district energy schemes.
Yeah.
At the moment, there's no data center associated.
Okay.
So we're refurbishing with new assets or we're building new projects in Greece. However, if a data center operator worked with a district energy developer there would be a natural off-taker for the heat from the data center that could be used and used more efficiently.
Okay, I see. Well, thank you for sharing that very interesting point. We're jumping now to the final part. First question is whether you would like to plug or promote anything to our audience. This is the moment for it right now.
The most important thing from my perspective is working with a quality supplier like Clarke Energy, able to give long-term availability and performance for a project. So if you have a project that needs reliable power, don't just think installation, think about installation and after-sales support, and that's where we can help.
And now the final question that we all ask to all of our guests is, what is your contrarian view on the energy industry that many people would not share with you?
Yeah, so I come from the organic waste sector and from the biogas sector. Anaerobic digestion of organic waste, properly deployed globally, could contribute to around about 11% reduction in carbon emissions. From a US perspective, yes, there is biogas sector, a lot in the cow manure, a lot for landfills, but there's a huge under penetration from organic waste treatment. The US, if it started to better connect domestic households to waste treatment networks, there's in some areas 50% of houses are on septic systems. If food waste was better collected and not dumped in landfills, this organic waste can be converted to biogas, injected into the gas network. And with support from the data center sector, the ones that identified this as a fuel they were willing to pay a small premium for could stimulate that market and have, big knock-on benefits. One for decarbonisation of the data centers, or defossilization, I should say, as opposed to decarbonisation. And it would support the reduction in emissions from organic waste. I think septic systems account for something like 75% of the emissions from the US waste treatment sector. And there's not a lot of drive to do that.
And have you ever studied any regions within the US with higher potential for these solutions?
So I'm from Old England, living in New England. Yeah. In Boston and around those areas, surprisingly, the penetration of septic systems is particularly high. Yeah. So in East Coast US, I think there's a huge opportunity to do more. Most biogas projects are centered around California, which is driving the market, or the Midwest, where you have the agriculture. But I think that the East Coast has huge underpenetration on the food and human waste side. And then if you look to other parts, I've been to sites in California that are still uncovered lagoons of organic waste, yes, which are emitting methane, literally bubbling straight to atmosphere. Capture that, use it to decarbonize the gas grid further. There's huge potential.
And for our audience to really understand in simple terms what it would translate to an actual work to be done, you will need to build a biogas plant generating power, but at the same time, you would need to build all of the infrastructure behind to process that waste and transport it. Is that correct?
Depends on the sector. On those uncovered lagoons, yes, you pretty much need to just capture the gas and convert it. In the waste sector and the household sector, there needs to be support for households to connect to a centralized sewage treatment network. And then from the organic waste side, people need to collect and treat food waste separately from the rest of their bin, i.e. separate collections or separate collection stations that have localized anaerobic digestion systems that has been deployed widely in other countries.
You mentioned the small price premium for those solutions. What are we talking about? Do you have any
I don't have the potential figures off my head, but I think it's in the region of 20 to 30% higher than natural gas. Okay. Still significant, but nonetheless.
Well, I'm sure that some of the developer actual loads will think about this solution. This might open some doors.
I hope so.
So, Alex, thank you very much for joining us today. It was a pleasure to have you here with us. And thank you for sharing such an interesting contrarian view.
Thank you. Much appreciated.